Hey folks, Wednesday, and you'll notice I have this pen right here, or pencil, whatever it is. It's there for a reason, because I actually did the entire mini movie before, and I had the paper over like that, so you could, for the entire thing, you had actually no idea what I was doing on that side. So I'm going to be mindful of that. And if I move that pen, or it gets moved, I need you to yell. I won't do any good, because... whatever. Okay, we're going to continue on with dilutions because that's what we are doing. The solution to pollution is dilution. There you go. We're going to use, I call it the super important dilution equation. And it looks like this. Old volume multiplied by old molarity 1 over a new volume spits out a new molarity at you. So it's kind of cool. We've got a formula. Like we never had that in chemistry, but it actually helps out. But I am going to turn this problem up a notch. Oh, see, I was about to move that pen. I'm not going to do that. It's just, okay. We're going to chair a bit. Here we are. All right. Here we go. You ready? You have 15.0 mils of 3.21 molar sodium carbonate. And you can now read that, in fact, it is carbonate because it's not buried underneath me. Yeah, okay. Continuing on, it is diluted to 75.0 mLs. Now, this is going to get a little crazy. It's going to get a little crazy. What is the new molarity of Na plus ions? Now, let's think about this. Sodium carbonate. Na plus means CO3 2 minus. I'm going to do JT it. That gives me Na2 CO3. We have done this a gazillion times. And that too, what's the chance we're going to be seeing that in the problem? I've still not moved that pen, so I'm doing well. I can slide up though, but not a lot really. Okay, anyway, how's the focus? Focus is looking good. Okay. Well, to make this work, you just got to find the right numbers and put them in the right place. So the first thing we have to do is we have to find an old volume. Well, it's not going to be that because that's molarity. And 15 mils is diluted to 75. There's always kind of a before and an after. Well, that is the old volume. I'm going to knock it into liters right from the get-go. 0.050 liters. Now, it is going to take 3 brackets to pull this stunt off. Crazy, huh? Here is my old volume. Now watch this. See this 3.21 M? I'm going to unpack it into its bracket form. Now I am going to start to get picky on this because it is in fact 3.21 moles at the top of Na2CO3. Mole. I have been seeing quite a bit things that would look like 3.21 M over 1 liter as a bracket. That's wrong. M is already a ratio of moles and liters, and I do need to see my stuff always. So, you know how to do this. Okie dokie. Now, I want Na plus ions. See that too? Watch this. 1 mole Na2CO3 spits out 2 moles Na plus. All right. This is the old volume. The combination of these 2 brackets is in fact the old molarity of Na plus, which is exactly what we want. Now to finish this whole thing off, I need 1 over the new volume, and that's, here we go, 0.0750. .0 liters. I'm going to get my calculator out, and my pen's right there, so I cannot go over that. And so you should be able to, well, yeah, I'll put it there. Here we go. 0.015 times 3.21 times 2 divided by 0.075. There you go. Now, I'm going to do a 3 in, 3 out round. 1.28 molar, it's moles divided by liters here, that is molarity, of Na+. There's my answer. Let's not forget significant figures in rounding. We've been doing it all year. 3 in, 3 out with a round. I've been kind of casual on it because, you know, we're in this new crazy world, but let's just start. Well, let's just keep doing all the stuff that we've been doing all year long because we spend so much time doing it. Thursday, I am going to be holding a Zoom chat for every single one of my classes. And I've actually posted on Canvas when it's there. At this point, it's not worth points. So the reason that you would come in is you just want to, I don't know, see your friends and you can talk to me. And if you got problems, you can talk. I'm going to keep it very casual like that. If everything's going fine and you've got tons of other work, well, that's fine too. So, and there is a chance that it may not work anyway. So, you know, who knows, right? Friday, there is going to be a quiz. Now, and let's keep in mind our due dates, Thursday, 6 o'clock. Everything in terms of practice problems that we're doing this week, it is due. Now, you can hand those things in earlier. In fact, I recommend it because I'm quite happy to look at what you did, and if there's an issue, I'll ask you to do some corrections. You can ask me questions. But ultimately, Thursday, 6 o'clock, all this practice stuff, it is due. It is done. I need to move on. Please don't send me an email at 6:03 saying, I got locked out, I can't submit it. Just, no. Get it done. And then Sunday, 6 p.m., I want the quiz. So that's that. I'm going to have some practice problems for this, and I'll start chipping away at it. Sound good? Okie doke. Bye.